Last year, my algebra teacher wasn't the greatest. He didn't go over the stuff, didn't make sense. I was getting 30s and 40s. Then we found Jay. His videos are great because I played sports. I didn't have a lot of time. So you start the video, come back to it later, finish it. At the end, there was notes that you could use for studying, review. And then you can review with him one-on-one. And that helps a lot because it's convenient. It's through Skype. And after reviewing with him, going through all that stuff, I was impressed. I got 80s and 90s, and it helped me a whole bunch. This year I'm in geometry, and over the summer I watched his videos, and I tutored with him. It's great because he's like a coach, it's one-on-one. He knows how to help you and knows what you need to do better. It's great now because I'm getting 80s and 90s again.
Oh, welcome.
And
So
next
you're
year
are you the student that I'll be
and I highly recommend his services.
studying with today?
Yeah.
Okay, welcome. Good to see you. So we're going to learn about Algebra 1. So you excited?
Yes.
Okay, well, I'm glad to hear that. A lot of the students that I get actually only come to these study sessions because their parents say they have to. But in your case, you're that 1 in 10 who's actually excited to learn the material, and I'm glad to see that. Glad to see that. Okay. The way I approach this is that, I try to make it so that you'll be successful in your course when you get back to school. Okay, we're not going to learn everything that there is to know about algebra during this short set of study sessions. What I'm trying to do is present the material in a way that it will make sense to you when you go back to school, and that you'll be able to do really well when you go back to school. So this is not supposed to be a standalone sort of thing. You're supposed to do it in conjunction with formal classroom instruction. Okay, so you get that. Okay, so the expectation is not that you're going to know everything about algebra. It's just that you'll be well prepared when you get back to school to understand what's going on and do much better than you would have if you hadn't participated in these study sessions. Okay, and another thing about these study sessions is that, it's informal, it's relaxed. No one is watching over us. And so, just be yourself. And, I'm not going to be like a teacher telling you everything. It's going to be interactive. In fact, many of the problems or questions are going to be questions that I haven't prepared for, I haven't seen. And I like it that way because I want you to see how it is that somebody who's more experienced approaches difficult, complex problems that they haven't been exposed to or that they haven't seen before. There's a certain way, and this is one of the things I'm going to teach you, there's a certain way that you could approach problems, including problems that you haven't seen before, and still get the right answer. And so that's one of the things I want you to take away from these study sessions. Okay? So I think we'll begin. If I can see your book and just flip through and see what you're expected to understand, then I can know what to focus on during these study sessions. Oh, by the way, for these study sessions to work well, it's expected that you'll go home and read through your book and try to find the sections that correspond to what we discussed and do problems. You have to do practice problems on your own. Otherwise, everything we learn in the study sessions will just disappear from your memory. So you have to reinforce it and commit it into your memory by practicing. Whether or not I give you specific assignments, that should be a habit that you develop, just working on problems. Okay? These problems aren't like torture or anything. They're fun. Solving math problems, to me, it's just like doing a puzzle. So it's fun, you know. And that's why I don't believe in assigning homework. You know, I think you should just flip through the book, find problems, and do those problems because you enjoy solving problems. Okay? Okay. So it looks like the first part of your book, the first chapter, is basically a review of things that you should have done or you should have known in the course before last year, you know, pre-algebra. You should have covered much of this stuff. But the thing I noticed, and this is with most textbooks, and this is possibly why a lot of students have trouble with algebra, is that the information that's presented here is not structured in a way that makes it easy for people to know what's going on and what to expect. And so that's what I'm going to try to do. I'm going to try to organize the information that's in your book so that it's easier for you to remember and easier for you to get it. Okay? All right. I think we should begin with, you know, you're probably wondering, if you're like most students, you know, you take algebra because someone said you had to take it. Okay? It's not because you want to take it or you know what it's about, but someone said you had to take it. And so I think it's always good at the beginning of an algebra course to let the student know why algebra is important, you know, what algebra is. And so basically the starting point in these study sessions is going to be my asking you whether you know what algebra is about and us trying to sort of understand in a very simple way. You know, by the way, in these study sessions, a lot of things aren't done in a formal fashion, the official fashion that you'll get in class. This is sort of, we say things in, you know, you use very loose terms in order to say things in a way that's easy for you to get it. And it's okay. So having said that, you know, I'd like to ask you in your own words, you know, what's algebra? What's algebra about? You know, why is it important?
I'm not sure.
Oh, you're not sure? Okay. Well, that's a good answer. Algebra. I would say algebra is a way of taking a real world situation where there's something unknown, something you're trying to figure out, and then changing it into mathematical symbols and solving for the thing you were trying to figure out. Okay? So, and I'll tell you exactly what that means. So, algebra is just a way to take a real life situation and turn it into mathematical symbols that capture the relationship among different elements. Okay? That's a loose definition. I'm sure that's not what you'll find in your book, but that's a loose definition. But let me explain what that means. For instance, you guys could be driving on vacation, and you know, and you just left the house about 5 minutes ago, and you know that your destination is 400 miles away, and you're trying to figure out how long it'll be before you get where you're going. And so you look at your speedometer in your car, and you see that you guys are going at 60 miles an hour. And so based on that, you can use algebra. Algebra enables you to take that situation, turn it into a mathematical expression, and solve for the length of time or how long it'll be before you get to where you're going. So algebra is actually very useful in many different situations. That's just a very simple example. So a lot of things in the real world that you're trying to figure out can be turned into mathematical symbols, and then you solve for it, and you have your answer. So that's what algebra is about. So when doing all this, you end up solving for some unknown, like the time, okay? In most algebra expressions, you'll be solving for x, okay? So there's always some unknown that you're trying to solve for, all right? And in trying to solve for that unknown, you can go through a couple of processes. One of them is to simplify all the symbols that you wrote down. Combine them. That's what simplifying means. Initially, when you're turning that real world problem, a situation, into a math equation, you write a whole bunch of symbols, and then you combine those, simplify them, and then it's easier for you to solve for the unknown. Okay? So much of algebra will consist of, in your course, throughout your course, they'll be asking you to evaluate an expression or simplify an expression. Okay, the simplification part is just combining all these symbols so that you're down to a few symbols that are now easy to manipulate and solve for. The evaluate part is when you have not just one unknown in the equation, say you have two unknowns, and then they say evaluate the expression for the first unknown, given a value for the second. Okay, so going back to our example about the vacation trip. Okay, say, you know that the distance is 400 miles away, all right, and you're trying to find the time. Okay, at this point, you don't know the time. You can't figure it out. You can write all these symbols down, but you can't figure it out. But you do know that the time is some combination of the speed and other time and other things. So if somebody says evaluate this expression for the time, and he tells you what the speed is, or you look at the speedometer, okay, now you can evaluate the expression for how long it'll take you. Okay, so throughout algebra, even though our main goal is to solve for that unknown, you'll have to simplify expressions and evaluate expressions also. Okay, so just be mindful of that, so that you know why, because a lot of students wonder why. They're given a question to simplify, and they want to solve for the unknown. They don't understand that simplifying doesn't mean solve for the unknown. And sometimes they're given an expression to evaluate, and they don't know what's going on. So just keep that in mind. So I've been talking about these symbols and these expressions, and I haven't shown you what they look like. Okay, so I'll give you an example. An example of the sort of mathematical symbols that you get when you take a real-world expression and you use algebra to form an algebraic sentence is something like this. Here's an example. 3x squared plus 4x minus 4 plus 3x equals negative 4 plus 5x cubed. Okay, so that's an example. So your objective I hope you can see this equal sign. Maybe I should highlight it. Okay, so that's an equal sign. So your expression will be the solve for the x, the unknown. Now, in doing that, you might have to evaluate or simplify or combine different terms, okay? Regardless of whether you're evaluating or simplifying, you have to keep in mind what they call order of operations. You have to combine each of these elements in a certain way. Yeah, I know I'm talking in generalities right now, and that's fine. We'll see what I'm talking about more clearly soon. Basically, when you're going to combine these things, these elements, I'm calling each, this is an element, that's an element, that's an element, that's an element, that's an element. When you're going to combine these elements and simplify this set of symbols, you have to follow what they call order of operations. You have to combine them in a certain order, okay? And there's an acronym. Have you ever heard of any acronym that helps you combine? You might have done it last year. Do you know what an acronym is?
Yes.
Okay. Do you know an acronym that helps you to know which operation you attack first if you have an algebraic equation like this or an algebraic expression? Do you know any acronym? You don't? Okay. There's an acronym called PIMDAS. Okay, that it's really useful initially so that you understand or remember what's going on. But after a while, you'll be doing so many problems that you won't need to remember this acronym. So basically, when you're going to combine or simplify or evaluate expressions, you don't always necessarily go from left to right, okay? When we read, we start on the left and we go to the right. You don't necessarily do that. In general, in a way you do, but when you come right down to it, you don't. What you do is you follow this order. You start out with the things that are in the parentheses, okay? You start out with expressions in parentheses like this. Okay, these should be combined first if they can be combined, or evaluated first if they can be evaluated. Okay, so the parentheses should be taken care of first. Then the exponents are second. Okay, so these are exponents. These are exponents. Okay, so basically, when we say exponents are taken care of first, is you look at this x squared, x to the second power. You think about that first before you think about the 3, even though the 3 is on the left. You deal with the exponents first. And then multiplication. Whoa, I'm running out of room. Then multiplication. So you multiply. Actually, I take it back. Multiplication and division are in the same order of priority. The only thing is, whichever one is on the left, as you read from left to right, whichever comes first, that's what you do first. So multiplication and division. After you've taken care of things in parentheses, evaluated exponents, then you deal with multiplication. This 3 multiplying the x squared. There's 4 multiplying the whatever is in the parentheses, the stuff in the parentheses. Okay, so you deal with multiplication and division. After you're done with multiplication and division, you deal with addition and subtraction. Okay? So that's the order of operations. Now, the next thing I'd like to talk about is the terms that are used, the words, the names that are given to different elements of this algebraic system that we create, this symbolic system that we created. Okay? Let me get the book out of the way for a second. You need to know these words, this vocabulary, because you'll be using it all the time, and you'll probably be tested on it also. Now, there's some books that define an equation as a math sentence that uses an equal sign. Okay? So you're supposed to know what an equation is. And as I told you, the whole thing about algebra is you're trying to figure out some unknown. So at the end, you're going to say x equals 5, or time equals 2 hours. There's going to be an equal sign. If not an equal sign, there'll be a greater than sign or a less than sign. Okay? So the first set of symbols that you put down, usually, if you're modeling a real-world system or trying to figure out something about a real-world system, is going to be an equation. Okay, this is an equation because it has an equal sign. Okay, so an equation is, I'm going to say, a bunch of symbols with an equal sign. Okay, and the equal sign usually correspond to, in English words, is. Okay? So equal sign means is. Okay? So that's what it corresponds to. Now, in addition to equal sign, as I mentioned before, you can have a greater than sign. You can have a less than sign. You can have a greater than or equal to sign, less than or equal to sign. So, and in fact, you can have a not equal to sign. Okay, so these don't really make the mathematical operations radically different. You do the same procedure that you would do if you had an equal sign. You just keep in mind that you have a greater than sign or a less than sign. Okay, so that's what an equation is. Another term, let me just underline this. So that's an equation. Another term that you'll be, another word that you'll be expected to know is an expression. An expression, the book definition of expression is a math phrase that includes numbers, variables, or operations. Okay? And that's actually a good definition. That's actually a fairly simple definition. So basically, any combination of variables, any combination of symbols other than an equal sign is an expression. For instance, going back here to here, this right here is an expression. You can say this is an expression. You can say the whole thing is an expression. You can say that's an expression. Okay, so I'm going to just copy the book definition, which is a math phrase that includes numbers, variables, and operational or operations symbol. Okay, a math operation is plus, minus, multi, times, divide. So I'll give you an example of an expression. So this is an expression. Okay? So that's an expression. So now that you know what an expression is, the other thing that you want to know is what a term is. Do you know what a term is?
Oh.
Oh, you don't? Okay. A term is just a number, a variable, or a product of a number and variable. Okay? So going back, I have to keep referring back to here. This is a term. This is a term. This is a term. Okay? So some examples are 3x squared. That's a term. It's a product of a number and a variable. That's a term.